Welcome to Landwards, the podcast for the land-based engineering community, brought to you by the Institution of Agricultural Engineers.
Welcome to the Landwards podcast. We are joined today by Dr. Mark Cooper, who, as well as being an eminent agricultural engineer, is a dear friend and professional mentor of myself from many years. So, hello, Mark.
Hello, Andy.
Thank you very much for joining us today. I have the advantage over the listeners in that, obviously, I know your backstory and we've worked together well for a reasonably long time. So why don't you tell us what you do and how you got there?
Well, as Andy said, my name's Mark Cooper. I've been associated with the institution for embarrassingly, something like 40 years now, having done a degree in agricultural engineering at Newcastle. This is back in the day when Newcastle had just left as a college of Durham University. But my particular interest within agricultural engineering is the investigation of serious and fatal accidents that involve agricultural machinery, and in particular vehicles such as tractors, telehandlers, shovel loaders, a whole range of pieces of equipment which have got the habit of, unfortunately, injuring and killing people with great regularity and repeated over many, many years. And we don't seem to learn how to avoid these things. But anyway, that's my current job and background. So I started off in the agricultural engineering field, but if you look at some of the machinery I've just mentioned, that now turns up in all sorts of different fields, mainly construction, quarries, aviation. All these different fields use equipment that was primarily designed for agriculture. So when things go wrong, people look at, well, where's the underlying theory to this? What makes vehicles stable? What makes them unstable? Those sorts of considerations come back to the agricultural engineer. But anyway, that's where I sort of ended up. But I started off when I left Newcastle, joining what was ADAS, Agricultural Development and Advisory Service, which was part of Ministry of Agriculture, Fisheries and Food, MAF. And they had a team or group that dealt with agricultural mechanisation. It's actually based at Rest Park at the time. But it was a civil service post. And whilst I enjoyed greatly the work, I'm afraid I never was destined to be a civil servant. I think I was at that age far too ambitious, wanted things to happen much more quickly than they did. And ADAS at the time was a very gentlemanly, sedate, considerate, academic type environment. And at those days, we still had a few individuals who'd worked in for the war agricultural committees. So they were long in the tooth, coming to the end of their careers, but still had an influence over people who were joining in the early 80s. But interesting times. And I think some of my colleagues from those days have found new posts, new ways of doing things in a much more commercial aspect of what would have been MAF. Anyway, when I left ADAS and having had a lot of discontent, I then went into industrial training. I worked for one of the industrial training boards, and that was again another Foreign and Commonwealth Office type organisation with people it was all very sedate, very hierarchical. Everybody knew their place. Their seniority in that position told you where they were. And I did that for a number of years. And it was looking at heavy machinery, how apprentices fulfill their apprenticeships, typical trades, fitting, turning, milling, tool making, those sorts of activities, which were prominent then, but over the years, we don't see so many of those types of folks. But then while I was there, I met a guy called Professor Richard Booth at Aston University. And this was the start of my academic career. And the reason that I was recruited onto the academic staff there was Aston had a long-term contract to train new inspectors who joined the Health and Safety Executive. There was at that time a specialist agricultural inspectorate, and there was nobody on the staff at Aston who got that sort of agricultural background to supervise projects, to give specialist lectures and so on. And that was how I joined them. So I started off as a teaching fellow, principally looking at vehicle stability and vehicle safety. And that was really my start of my interest in occupational health and safety. So if I was to say, where do I sit? It's in between agricultural engineering, occupational health and safety, mechanical engineering, and where those overlap is probably the little domain where I reside.
Dr. Cooper's professional Venn diagram, shall we say?
That's exactly right. Exactly right.
Let's just wind the clock back even further, and let's have a think about your early education and your choices and your light bulb moment, or possibly general drift towards agricultural engineering. So possibly sort of pre-degree, if you like to call it that.
So growing up, we lived in a very rural area, and when I was about 14 or 15, I worked on the local farms, and we drove tractors and machinery at that age in those days. And so I was very interested in that side of things. But also at the same time, my academic route was A levels, and in particular, maths, applied maths, pure maths, physics, which gives you the really solid background for an engineering career. So I got the engineering from the subjects that I did at A level, and then my interest in my everyday life was in agriculture, and it didn't seem a great leap forward to think about agricultural engineering. But in my youth, I did not know that such a subject existed initially. And it was only after looking at different possible subjects that there's a couple of places that do agricultural engineering. That sounds like what I'd like to do. So I got into it that way. I also spent some time in sort of rural Herefordshire on hop picking and the drying of crops, and began to understand that the sort of science behind these things, and there's good ways of completing the task and not so good ways, and it's that's where the engineering and the overlap came in.
You also you mentioned you did a bit of time on a kibbutz in Israel, Mark. How did that influence you?
I think several ways. One, countries or places that you'd heard of, biblical places that you'd heard of, to actually go and see when you were sort of in your late teens was a very, wow, this is, yes, that's interesting. I've heard of these places. Then to go and see them. So I was in the Negev desert, and it was literally sand. You were right on the border with Egypt. You couldn't grow crops unless you nurtured them. So irrigation systems were very important. And I can remember vividly every morning we used to have to go out and put all the irrigation pipes back in place after the tanks had been in overnight on their manoeuvres. That's the sort of how far into the desert we were. But it just showed you the miracle. If you knew and could provide the right nutrients and the right environment, you could quite literally grow anything anywhere. That's the sort of what I came back with. The social thing, you can become very blinkered living from being brought up in a rural area. Your view of the world is very narrow.
Yeah.
You go back and see, there's tremendous conflicts there. Security was an issue, but equally wonderful sights that you could see. I can remember very clearly seeing the Dome of the Rock, just gasping almost in how wonderful it was. So seeing those sights and those things, and to this day, I'm still interested in that area of the world.
Yeah, so you've sort of it sparked a lifelong interest there, didn't it?
Yes.
Going back to Newcastle, then, have you any other reflections on your time studying agricultural engineering at Newcastle?
Well, the first thing was, again, very, as I've said before, very clubby, old school environment. We had small tutorial groups, and some of the people were national leads in their subject area. We had one chap, and he'll be known to many folks, Professor Alan Rees, Dr. Alan Rees. He was a philanthropist in the end. He had a very interesting specialism, and it was in soil mechanics. But soil mechanics don't just apply to the sort of agricultural environment. He used it in terms of developing underwater plows to bury pipelines. Now, why would you want to do that? Well, the pipelines offshore actually move in the currents. So if you want them to stay put, burying them is a good idea. But in the process, you also insulate them, which makes the contents of the pipework flow more easily. But he developed basically a plough that fitted on top of a pipeline, was towed by a tug, and it lifted up the pipe, dug a trench, and as the pipe was returned into the trench, he calculated the angles based on the soils and the knowledge of the environment that they would self-collapse. So the pipe was then covered with this underwater soil in one fell process. And he made an awful lot of money out of that and became a philanthropist. And to this day, in the northeast of England, he's got a foundation which he, sadly no longer with us, but the foundation helps to encourage youngsters into practical subjects like engineering. So, very interesting times, interesting characters. Not to be, I don't think it's like that these days. But the other thing that I felt was the multidisciplinary nature of the subject. If you take one that we studied in detail, hydraulics, that's one of the subjects that is not readily taught in your average engineering degree. There's a very creative process to develop hydraulic systems, but that is transferable. And I think this is the one useful thing that I would say to anybody doing agricultural engineering. It's such a multidisciplinary approach that you can actually use it and apply it in all sorts of different fields that don't necessarily have agriculture written on them. The principles apply. Thermodynamics, grain drying is similar in that respect. It's got this much wider application. I also remember very distinctly when I went to university be called Mr. Cooper for the first time. Nobody called me Mr. Cooper at that stage. So it was all very respectful and all very genteel.
You don't get the same via a degree via Zoom nowadays, I suspect, Mark, do you?
No. And we were quite fortunate that, tuition fees were all paid for. It was a sort of a different funding structure.
Yeah, the halcyon days of, I was about to say something like proper education, but I should imagine we'll get some fan mail if that's the case. So, but as you say, a different land, let's put it that way. Shall we maybe just sort of move on a little bit and talk about the steps you've taken through education and work to get to where you are now?
So I mentioned that I was brought up in a rural area. My parents were reasonably well off, but the school that I went to, the catchment area, it was from a very poor, impoverished part of Wales. And I learned quite quickly that the way out of poverty, and I still think this is true, certainly true then, the way out of poverty was education. And not every parent had that, understood that, or supported that. But the people that did do well at school and who went on to university, that, being blunt about it, was a way out of the poverty that some people are still, unfortunately, affected by. So I was, at an early age, quite clear education is a good thing and it pays off in the long term. And so I know today is the day when A-level results are out, and it's one of the things that if people just looked at it and say, it's going to cost me so much money to go to university, it might not be worthwhile. I think there's more to it than that. It's not just the financial benefits that you might get from having a degree or an education. It's, it improves one's mindset, it improves your outlook, your values, all those things can be affected. So that was the sort of the first big decision in life, to go to university when the vast majority of people didn't. And so that was fine. And when I left the Ministry of Agriculture, I also got another opportunity to go and do some education, which I did. But later in life, I was made redundant and I had an amount of money. And I had an opportunity to finish my PhD, which I started, or I could have gone looking for other jobs. And it was a very conscious decision. And it didn't sound a lot of money these days, but it was something like £15,000 is what I was given. And I used that to subsidise me for a year to finish my PhD. Rolling the clock back or forward 30 years, was that a worthwhile thing to do? Yes, I do. No question that it was a good thing to do, because it's led me on a different path. The ability to earn money was changed by doing it, and so on. So, but at the time, that was a big decision. Should I invest in myself or not? And there was no guarantee at that point that you get the money back. But if you take this broader view, investing in yourself is a good thing. I would just encourage people to do that. It's worked for me, and
I'd echo that entirely. Churchill had a great phrase about, ask not what your country can do for you, but what you can do for your country. So I'm gonna steal that and do it the other way around and say, Mark, what's ag engineering done for you?
That's an interesting question. So if I was to say today, in any work that somebody sent my way, I would draw on things that I'd done at university and the experience subsequently. So what's agricultural engineering done for me? I would say it's provided me with a good engineering grounding, multidisciplinary, the ability to look at machinery and to try and understand what's going on. Not everybody can do that, but this idea that that leads to that, that isn't working because that fault finding ability to be able to picture in your mind what's actually occurring in this process has been very useful. But it's provided me with a career, a specialism. It wasn't one that I set out to take, but that's where. So I've ended up in this, as you very neatly said, the Venn diagram. That's the agricultural engineering part of it. It's the thread that goes all the way back to the first days in my career. And a lot of work is that I've done is advisory work. Again, these are common principles. Doesn't matter what discipline you've got, being able to give people advice without upsetting them is a useful skill.
Sensitively delivering the news people don't want to hear.
Yes, and ADAS was good for that. Actually, we sometimes farmers didn't want to hear the advice we were giving. Doesn't mean to say it's the wrong advice. It's just didn't land correctly.
It's delivery is all, isn't it? We are, obviously Landwards as a podcast is a part of the Institution of Ag Engineers. I just wondered about your professional progress as a member of the institution. I wondered if you'd give us a little bit of an insight into the steps you've taken over the years.
Well, it's almost linking to what I've just said. ADAS were brilliant in terms of providing structured training. At that stage, I don't know, across the whole of ADAS, they may have recruited 25 or 30 graduates each year, and they provided them with a training program. So I had that, I was fortunate enough to have that, but that then turned out to be really, really helpful when I was interested in going for corporate membership and chartered engineer, because I got the logbook, the structured training program that said at the beginning of the year what I was going to do, evidence that I'd been on the course. Wonderful, is that nuggets of gold. So that sort of helped me to get that. And I think of all my achievements, chartered engineer is the one that I'm most proud of. So that's how I got to that. I've been very fortunate to be on the membership committee of the institution for a while, vice president for 2 years, again seeing how the minutiae of how the institution works, and then very kindly invited to be a fellow, and here I am, zoom forward 40 years membership.
And I was just thinking about your day job, and we have a few parallels between some of the work which we both do, but there is no such thing as a typical day, is there? But I just wonder whether you were happy to reflect on how you use your agricultural engineering in your day job and what that can sometimes look like.
So maybe if I go back and pick out a particular case that I did some while ago that perhaps typifies what my work involves. It's looking at pieces of equipment in which, unfortunately, people have been seriously injured or killed. And there's always a danger with that, because if you're going to examine a piece of equipment that has already killed somebody, you know that you've got to be really, really careful about how you plan your work to investigate how this machine operates. Because there's no good looking at a piece of machinery when it's stone cold, doing nothing. You've got to be able to plan and think about, how do I get a fair representation of the circumstances that led to this incident?
Yeah, the phases of the machine life, as it were, or operation.
Yeah, absolutely. And then leading up to, and what actually what could have happened, what could have brought that set of circumstances about that led to this person being trapped or injured as they were. So in amongst all of that, there's a lot of design standards these days. So you're always looking at what the basic principles of civil machinery are. Give you an example: unexpected startup, that's to be avoided. Unexpected startup is a key cause of a lot of incidents. So what you need to know about how a machine, what the controls in place are to avoid unexpected startup, and then, well, how might it occur? What might happen if that safeguard was defeated, or that one, or two of them? So the idea that you go back to these sort of first principles: here's the design of machinery, here's the standards that relate to this particular, let's take, for example, bale wrappers could be an example where you would look at what the standards are, and then you look at the machine, you look at the standards, and you try and come to a judgment about, is this compliant, and how might it have been defeated to enable the injury to have occurred. So it's a sort of it's fault finding, but fault finding gets better with experience. So you can say, oh, I've seen something quite similar to that before. But each thing that you do builds that database, that mental database of how things can not go as per plan, how people may defeat the well-intentioned safeguards that are there. Yeah. So, yeah.
Is there any specific jobs you'd like to reflect on? I mean, I know you and I have done a few jobs together in the past, but without naming and shaming, is there anything you think where you think, oh, maybe that wasn't agricultural engineering initially, but as the project went on, the ag engineering came to the fore?
Probably 25 years ago, nearly 25 years ago, you and I were involved in looking at the safety of security devices in banks and building societies. And basically, without giving a long explanation, there are bulletproof screens that sit within the counters in banks and building societies that can be activated and provide a safe, secure barrier between the customer, the rogue customer, and the staff, protecting the asset, protecting the money, protecting the individual. And we were asked to look at some of these devices that went off unexpectedly. And going to the agricultural engineering part of it is, it was all run on pneumatics. And very quickly, as an agricultural engineer, you could look at the system, you could work out what you thought the pneumatic circuit would look like, and then you look at the control systems. And that, in the case that we were involved in, it was the control systems that were affected by, if I remember correctly, key fobs and other interferences.
External influences.
External influences.
People were locking their cars and triggering them, weren't they?
That's it. So on the face of it, nothing to do with agricultural engineering, but if you looked at the circuit diagrams that Andy and I would have put together, you'd recognize them as an equivalent of pneumatic hydraulic circuit.
Just sort of getting us to now, Mark. What challenges do you think, on the basis of your experience, what challenges do you think agricultural engineers are facing and will face going forwards?
I think there's more and more high-tech IT type requirements for agricultural and horticultural machinery. So it's so there's less hard-nosed mechanical engineering involved these days and more sophisticated electronics. But if I were to look at what are the challenges for an individual and what I might have learned along the way, and I think you have to be able to persuade people. You can have all the great ideas in the world, but if you can't persuade folks that this is the thing to do, then the best ideas go nowhere. And I have seen over the many years, some people are very persuasive in their written work, and other really talented people can put across a calculation or a drawing, but they can't provide that persuasive written document. Churchill had a phrase which is basically saying, just tell me what I need to know. If I don't need to know it, put it in an annex. And, I think it was page of landscape in those days. But on one page of paper, put your ideas. I don't want to know the rest. And that actually is a very difficult thing, Sorry, this letter is so long, I didn't have time to write a shorter one.
Indeed.
Absolutely true. It takes more skill to write that succinct document. And there's a book, and it's still published by a civil servant called Plain Words by Sir Ernest Gowers. And it was a guide to civil servants. Brilliant. And it's still relevant today. And it's about picking the right word, getting rid of the superfluous words that are just flannel, and other, quite a structured, avoiding using certain words that are just fillers. But that's a very great skill, and I'm as guilty as anybody else. These days, it's easy to get your phone out and do a dictaphone response to something. Well, that's fine. When you read it back, it is full of the fillers, the flannel. It's not succinct. So practicing report writing, I think, will pay dividends. So that was my advice to somebody who's a competent engineer. Honing your report writing skills, I would put as top of the list.
I must admit, I've been on quite a journey to say the right thing at the right time as an editor and as an engineer. So that is sage advice. And certainly when one's called upon to present one's CPD record for the Engineering Council to have a look at, you look back and think, I wish I'd written that a slightly different way. Mark, we're probably getting to the end of our recording now, so I don't know whether you want to conclude with a few sort of final reflections or an and finally. How does that sound?
And finally, I'll keep it brief. I do not regret for one moment studying agricultural engineering. Is one of the best things I've done. At the time, people were like, oh, I've never heard of that, and didn't know they did a degree in that. And so we sort of normalized agricultural engineering into the wider psyche, the wider, the wider environment. So that's a good thing. But multidisciplinary approach, again, is good. Being able to look at things from first principles, I think, is a key skill. And I think that's what an agricultural engineer does, a farmer does. When you go out to a show and you look at something, how does that machinery work? What happens? And people analyze it. And not everyone has got that analytical skill. So being analytical, that transferable skill is really helpful. And as I say, I don't regret it for a minute. I also think sometimes, and you and I know this too well, we have done jobs in the dim and distant past where we've actually helped somebody. We've helped them to understand the dire accident that occurred to them. Although it can't roll the clock back, it can help prevent a recurrence, but it can also give them some form of closure on why this horrible thing happened to them. And that, as I think, from a human point of view, is sometimes some of the best thing. Nobody else can explain it, but because of your engineering background and your knowledge, you're able to tell somebody, this is what happened. You've actually made a contribution to their recovery. So that would be my final note.
Well, Mark, I have a feeling that we could probably have carried on in conversation for several hours, subject to popping to the bathroom and having another cup of tea. But I would like to say thank you very much for a wonderful insight into your journey thus far and your completely pertinent and relevant notes around what makes a good agricultural engineer and the contributory factors. I've thoroughly enjoyed being in conversation with you for the last 40 minutes or so. Mark, thank you very much for your time today. I'm Andy Newbold, editor of Landwards, and I'd just like to say thank you very much to Dr. Mark Cooper. Thank you, Mark.
Thank you. And as always, Andy, we have very fruitful chats, and we sort of help each other out along the way.
Well, this has been a lovely interlude, let's put it that way, and I hope that the listeners enjoy this as much as I have enjoyed putting it together with you, Mark. Thank you, Mark.
Many thanks.
For more information, visit www.iagri.org. You have been listening to Landwards, the podcast for the land-based engineering community, brought to you by the Institution of Agricultural Engineers.